Hi everyone, today I'm going to be talking all about data visualization. We'll look at the different types of visualizations that we can create using Python and R, learn about the do's and don'ts of effective data visualization, and then take a look at some examples of what works and what doesn't in communicating results. To start, I'm just going to quickly go over the definition of data visualization, which is the process of representing data and information in a visual format, such as charts, graphs, maps, or infographics to make complex data easier to understand and analyze. Not just about making it look good, but about making it easy to pull actionable insights from. For example, this table right here would definitely be hard to pull anything meaningful from just by looking at it, but this pie chart can communicate the story at a glance and make it very easy to understand. And this just shows the power of data visualization is in the ability to communicate findings effectively. Now I'm going to talk a little bit about tools for data visualization. So obviously Python and R are two of the most popular programming languages, and they each have their own strengths when it comes to creating data visualizations. Python is a very versatile language in almost all areas of data science. When it comes to data visualization, Python offers a lot of flexibility with libraries like Matplotlib, Seaborn, and Plotly. You can create anything from basic charts to interactive dashboards. Python's also great for handling large data sets and integrating visualization into data science workflows. R, on the other hand, is designed specifically for statistical analysis and visualization. It's widely used in research and academic settings. It's easy to use with libraries like ggplot2, which allows you to create detailed and customized plots, and R is particularly ideal for tasks that involve advanced statistical analysis. Now let's look at the libraries used in each language for data visualization. So in Python, a few common libraries that are used for data visualization are, like I said, Matplotlib, which is great for basic plots like line charts like we have, bar graphs and scatter plots. Seaborn, which is built on Matplotlib, can simplify the creation of statistical plots, just kind of give a better aesthetic look. And then Plotly is great for creating interactive web-ready charts, and it's also ideal for dashboards. And then for libraries in R, ggplot2 is a popular data visualization package that's widely used for creating complex multi-layered graphics, and then also Lattice, which is used for creating multivariable statistical plots. Now that we've gone over the most popular tools for data visualization, I'm going to talk a little bit more about the do's and don'ts of effective data visualization. Firstly, effective use of color. Choose accessible and consistent colors to make your visualizations clear and easy to interpret. Something to keep in mind here is color blindness, so definitely choose color palettes that are clear and easy to differentiate. Next is to use clear labels. Make sure that your axes and legends are well labeled and also descriptive so that someone who's just looking at your graph and only your graph can understand exactly what the data is representing. Next, simplify complex data. Avoid overwhelming your audience. Focus on key points and use clean, straightforward visuals to make your complex data easier to understand. Definitely important to choose the right chart type. So bar charts are best for comparisons, line charts for trends, and then pie charts for proportions. And then finally, your data should, or your graph or plot should tell a story. So your data should guide the viewer through a clear narrative, highlighting the most important insights and making the concepts easy to grasp. So now I'm going to show a couple good examples of effective data visualization. First of all, we have this horizontal bar chart. It has good coloring, it's clearly labeled, and it's listed by the order of the most to least to give more of that visual aid and help the viewer understand the breakdown here. Then we have this pie chart, very simple but also straightforward. Good labels, good colors, and the percentages are listed as well. And then finally this scatter plot. The axes are clearly labeled. It all makes sense. Notice also how the axes don't start at 0. With regular increments, it starts at 75 and 80. Otherwise, it would create a whole bunch of empty space at the bottom. But with this scatter plot, all of the relevant information is right there in the main part of the plot. Now for the don'ts, or common mistakes to avoid in data visualization. First of all, don't overload with chart junk. So too many labels, too long of labels, or 3D effects can clutter your chart and distract from the data. Next, avoid misleading scales or axes. Make sure that your scales are accurate. Misleading scales or axes can confuse your audience, and obviously the goal is to make your plot or graph as easy to understand as possible. Next, don't rely solely on color. Color is useful. Do not use it as the only way to convey information. And then last, don't omit context or critical data points. Always provide enough context. Remember that omitting important data can definitely lead to confusion. For example, showing only part of a time series, like recent months instead of a full year, can distort seasonal trends and things like that. So now I have a few bad examples of data visualization, and the difference is very clear. So first of all, this pie chart here was probably not the correct chart selection for the data being displayed. And then over here, too many 3D effects in the bar chart make it really hard to understand. Overall, they're very cluttered, busy, way too much going on, not labeled well, and you really just can't understand them at all. To give a side-by-side difference, I created two simple pie charts with the same data to show effective versus ineffective data visualization. So on the left here, we have bad colors, not descriptive enough labels, no extra details, no percentages that would help the viewer understand what it is we're looking at. But on the right, we use some better, more clear colors, a more detailed title, we have a legend, we added percentages, all to give the viewer a better idea of what it is that we're looking at. And to conclude, here's a few key points just to summarize what I talked about today. Data visualization is a powerful tool that helps us transform complex data into insights that we can take action from and make decisions from. Python and R each have their strengths. When it comes to data visualization, Python is more flexible and R can be used for more statistical visualizations. Common mistakes to avoid are clutter, misleading visuals, or omitting important data. And then obviously follow best practices for data visualization, like using clear labels, appropriate colors, and accurate scales. And then finally, choosing the appropriate chart type to create clear visuals that turn raw data into clear, compelling stories. And then here are the references I used in case you guys wanted to take a closer look and learn more. Thank you so much for spending time watching my presentation. I hope you enjoyed.